Okay, so today we'll be completing the square. This is from your homework, worksheet 4.7, completing the square. Take a look at number 1. The directions say complete the square to convert each quadratic function from a standard form to vertex form. Give the vertex and line of symmetry for each function. Well, in order to complete the square, completing the square refers to having a perfect square trinomial. So we want to take a look here and see, do we have a perfect square trinomial already? And if not, then we need to create one in order to write something in vertex form. So the way we can check to see if we have a perfect square trinomial, in the same way that we actually create the perfect square trinomial, is to see, okay, if we have half of b and then we square it, does it equal c? Okay, so let's go ahead and check that. Well, so we have half of negative 16 squared. And does that equal 64? Well, half of negative 16, that's negative 8. And negative 8 squared does equal 64. So I already have a perfect square trinomial. So I don't need to do any extra steps to complete the square here. I just need to know how to factor this trinomial. So let's take a look here. We have x squared minus 16x plus 64. I already checked. It's a perfect square trinomial. So I just need to factor it. I need to think about two binomials. What two numbers multiply to 64 and add to negative 16? Well, I know I need to have an x in the front for both of these. And if I think about the two numbers that multiply to 64, well, it's either, I would think 8 and 8, or negative 8 and negative 8. And because I have a negative in the middle here, I know that they both have to be negative. I have to have two negatives in order to get a positive in the end and a negative in the middle. And it just so happens that it is negative 8. It's half of b. Because a perfect square trinomial, the definition is that we have half of b, it's x plus half of b squared. I'm going to make that a bigger square there. So now I actually have it in vertex form. If you remember, vertex form is y equals a times x minus h squared plus k. And if I rewrite this in vertex form, I have f of x equals x minus 8 squared. And in this case, my a is 1, my h is 8, and my k is 0. Well, vertex form is always h comma k, so in this case I have 8 comma 0. My line of symmetry is x equals h. So here my h is 8, so I have x equals 8. Okay, so let's take a look at one that now we actually have to complete the square for. Number 2. I can double check real quick to make sure that I don't have a perfect square trinomial where I take half of 8 and square it and see if that equals 11. So half of 8 is 4. 4 squared, that's 16, and 16 does not equal 11. Okay, so I need to complete the square. So I'm going to go ahead and actually erase this part right here so that it doesn't get into our way. Now that I checked to see if it was a perfect square trinomial. So here, what we need to do is we need to say, okay, I want to complete the square by making a new c. But I can't just get rid of that 11. What I'm going to do is I don't need it at the moment, so I'm just going to put it off to the side. So I'm going to do this where I have plus 11. Okay, and I'm going to, in parentheses, I'm going to rewrite the first part of my trinomial, x squared plus 8x. And remember, to have a perfect square trinomial, I need half of b squared, and that would be my ending trinomial. And we kind of checked that already. Half of b squared, so we have half of b, half of 8, squared we said was 16. So what we need to do here is we need to add 16 in to our perfect square trinomial. Well, we just can't add something to a function without changing the value unless we're adding 0. So what we can do is add an equivalent of 0. So if we add 16 here, we need to subtract 16 right here. And that's subtracting an equivalent, or adding an equivalent of 0. Then what I do is I think about my properties. I'm going to factor this. Remember we talked about two numbers that add to 16, or multiply to 16 and add to 8. Well, they both have to be positive, and we know that half of b is 4, so we're going to add 4 to both sides, to my factoring here. And then at the end here, we can just add these two together, and we get 11 minus 16 is negative 5. So the last step we want to do is rewrite these two binomials, since they're the same, as really a binomial squared. So I'm going to rewrite this as x plus 4 squared minus 5. And now I have this in vertex form. So my vertex form is f of x equals x plus 4 squared minus 5. And now I have my a, h, and k. If I take a look here in front of my parentheses, I have a, which is 1. Inside the parentheses, I have h, which is negative 4. And out here, I've got k, which is negative 5. And I'll just write those right here. A is 1. H is always opposite, negative 4. And then k is negative 5. So my vertex is h comma k. I should get negative 4 comma negative 5. And my line of symmetry is always x equals h, so it should be x equals negative 4. Okay, let's take a look at one last problem. And it's a little more challenging because we have a number that's in front of our x squared that's not 1. So here we have a negative 4 in the front. So I need to complete the square. Well, let's just double check. I really can't double check the same way I did before because of that negative 4. But let's go ahead and assume that it's not a perfect square trinomial, which it's not. So let's go ahead, and what we're going to do is we're going to factor out a 4 or a negative 4 from the first two, because I'm going to let that negative 41 kind of hang out here until we need it later. So let's factor out a negative 4 here. I have negative 4. And if I were to factor that out, I would get x squared in my parentheses. And then I really divide this by negative 4. So I get negative 6x. And then I have to figure out what I'm going to be adding here. So I think about the same thing now. I'm looking at this trinomial inside the parentheses, and I want to do half of b squared. Well, half of b is negative 3. And squaring a negative 3 is a positive 9. So I'm going to add 9 here. Now here's the tricky part. Because I factored out that negative 4, I need to multiply it by 9 and then add the opposite to the end here so that I'm adding that equivalent of 0. So here I have negative 4 times 9. That's a negative 36. But I'm going to then add 36 because I'm doing the opposite, and so that I can balance out my equation. So now I want to rewrite this as two binomials. And if I think about half of b, that's negative 3. So I have x minus 3 and x minus 3. And then over here, if I add negative 41 and positive 36, I should get a negative 5. And then the last step here is to rewrite this as a binomial squared. So I have negative 4 times x minus 3 squared minus 5. And if I rewrite that over here, and that is my vertex form, so I have f of x equals negative 4 times x minus 3 squared minus 5. And my vertex then, let's just think about what the a, h, and k are here. My a is negative 4, my h is a positive 3, and my k is a negative 5. So my vertex is h comma k, 3 comma negative 5. And my line of symmetry is simply x equals h. So this one takes a little bit more practice as far as making sure that when you only factor out the 4 from your first two binomials, or your first two terms, in your trinomial. And then when you do your half of b plus c, or half of b squared to get your c, that you then have to multiply it by whatever you factored out and add the opposite to the end. If you have any questions, please see me or Mr. Daniels. Make sure that when you're watching these videos too, that you're also pausing and taking breaks so that you're not trying to rush through and keep up with the video necessarily. Have a great day.